everybody, my name is George, and as you all know, we get a cut, we get wounds, we get infections. It's totally natural. But, what happens? What is there to protect you? Why do wounds heal, and why do you get an infection in the first place? It's all because of your immune system. Your immune system is the guardian of your whole body. It's saturated. 15 quintillion of immune cells float around in your body right now, ready to respond to any invaders that set foot on your body. So let's see what happens when your skin is breached. The skin is the outermost layer of your body. If you all know about it, then it will help in this video. So the skin, let's imagine you get cut by a needle. It's kind of like owie on the human sensation, but your cells inside of you had a totally different experience. For them, it was an ordinary day, and then suddenly this metal sharp asteroid pierced into the world and then ripped apart many of them. And then not all of them are ripped apart dead, but some of them are ripped apart dead type, but some of them have already begun to send out signals. They're distressed and hurt, and they're about to die, and then so they start sending out signals to anybody who's ready to respond to them. Immediately, your first line of defense, called mainly phagocytes. There are two types of immune cells: phagocytes and lymphocytes. Phagocytes are the first ones to arrive on the scene. The first phagocyte is a macrophage. Macrophages are pretty blob-like fellows that they have these fake feet and fake arm thingies. They're called pseudopodias. When macrophages bind onto, what macrophages do is called phagocytosis, which means that they just bind onto intruders with their sticky tentacles, pseudopodias, and then they swallow them whole, they engulf them whole, and then they trap them in a vesicle, and then they lyse them with acid from something called a lysosome. But what if this is not enough to stop it? So macrophages release out signals to the second line of defense: neutrophils. Neutrophils are kind of suicide bombers. They kind of along with phagocytosis, they also commit apoptosis to release their DNA out and to create toxic barriers that stun or kill completely the bacteria. But what if those are not enough even? They call on complements. They call to the blood vessels, using special cytokines that allow the blood vessels to open up and release fluids into the battlefield so that fighting becomes easier. How? Well, the complement system is in the blood. As you might have already watched in the complement system video. If you haven't, then just go to it. If you haven't watched my complement video, you should watch it, because this will really help in the video. But because the complement the bacteria don't really prefer to be grabbed, but the complement kind of makes it easier because it acts like a receptor glue, so that macrophages can bind onto it and suck the bacteria in, lyse them out. So, but sometimes, a lot of times, it's not always enough. Sometimes bacteria can mutate in such a way that they kind of employ defense mechanisms. Some might chop up immune cells, so they employ defenses. Now, that is when the dendritic cell kicks in. It's the hour of the dendritic cell. So dendritic cells are their job is simply to get drunk. They are they're like careful considerers of the immune system, and they also undergo phagocytosis. But no, this is not to completely like kill the enemy. No. Yeah, they do kill the enemy, but they don't entirely vomit it out after that. Nope. They take the leftovers and they put it on the surface. Like a warrior covering himself in a corpse of a dead enemy. And then from all that, it goes to the lymph system, the lymphatic system. That it's the tract that connects your whole body with the immune HQ. And there, millions or billions of helper T cells are waiting to be activated. Once they're activated, a beast will rise from the shadows to swing the battle, because once they're activated, they clone themselves. What they do is they clone themselves rapidly. This is an antibacterial force. And dendritic cells do another important job. They kind of consider which force to activate. Either it's only the helper T and B cells, or it could be other cells like killer T cells that can wipe out infected cells. So in this case, antibacterial forces. So it went into the closest lymph node and activated its T cells that it's looking for. So then hell breaks loose and the T cell starts cloning itself over and over. Well, these T cells now split into 3 groups. One of the groups stay in the lymph node and become something called a memory cell, which, if you don't remember, I'll tell you, is like a cell that remembers your enemy and keeps memories of it. Then some of them, the second group, goes to help out your soldiers, and the third group goes on to activate another powerful weapon, your ultimate weapon, B cells. Okay, so back at the battlefield, let's go back to the battlefield. Back at the battlefield, things are turning very gruesome for your soldiers. Your soldiers have fought with all their might, all their strength, but they continue to die in the process. And here, the helper T cells arrive. They stimulate those hard-working weapon factories so that they don't die so easily. The helper T cells, what they do is they release a special cytokine that can bind to the macrophage and neutrophils so that they don't die that easily and they stay alive longer, and they can kill the invaders. Like I told you, the complement resistance might not be enough. So back to the group that helps the B cells. So the B cells are like the ones that produce a weapon called antibodies. Antibodies basically are like little pincer crabs. They have pincer and the bottom one, and so what they do is they stick to enemies, and there's even different classifications of antibodies. We're not going to mention them in this video. So anyway, the helper T cell is looking for just a B cell that has a perfect setup for the virus or bacterium that entered you. And then once the correct B cell is found, it immediately starts cloning itself and turning into its final form of plasma cell. These can now start producing antibodies for real, and they flood the body with billions of millions of possible antibodies that can immediately saturate the body and stun those bacteria. And then hell breaks loose, because every part, adaptive and innate, are active. Now every part is active. So in a team effort, the virus is wiped from your body, out. And now to the final part. The thing is, the soldiers, your macrophages and neutrophils and helper T cells and B cells, realize that they're not needed anymore. And what they do is they commit a natural cell death called apoptosis. It's when they explode themselves, and their remains are cleaned up by fresh young macrophages and neutrophils that will take their place in patrol of the blood vessels and the body. And also, like I told you, some of these soldiers stay behind at the battlefield. They turn into there are 3 types of memory cells. I mean T-cell memory cells. There are central, effector, and tissue resident. And also some B cells also stay behind and turn into memory cells too. But now all is like done, and the soldiers have won. And then you look at your wounded arm that was once invaded with bacteria. Now it's like better. Now it's better a week later when you look at it. And you had no idea of the experience, all the drama that your cells had to deal with. For you, it was just a slight annoyance. But for millions of billions of cells, it was a fight, a desperate